My name is Jonathan Hicks. We're doing bearings. Now bearings are just a special kind of angle really. So I strongly recommend you go and watch the angles videos first and then come on to bearings. The bearings problems or questions that they can ask you can get quite hard. A lot of people struggle with it. I'm just going to explain the concepts in this video, what bearings are, and actually there's not a lot to it. And then I'm going to do another video where we look in depth at some of the tricky kinds of problems that they can throw at you. So what is a bearing? Well, it's all to do with maps generally. If you imagine this is a map and this is some point on the map here. Let's say this is where you are at position A, and somewhere else on this map is another position B. Often they like to do this at sea. So maybe this is a lighthouse or something and this is a boat and you're trying to find the bearing to the boat or whatever it is. But the bearing, in order to mark the bearing on the map, you need to know where north is. Now generally on a map, north always points upwards, and they'll often stick a north arrow on for you. They might put it at the side, or more likely they'll put it on one of the points. You need a north line at the point where you are though. They'll always tell you where your bearing is measured from, where you are at the moment, and in this case I'm going to assume it's from A. So we'll have a line that goes straight up from A, and that's our north line. So if we wanted the bearing, the way they word this is it's always the bearing of one position on the map. So in this case we're going to find the bearing of B, and then it's going to tell you where to go from. In this case we're going to go from A. So the bearing of B from A. Now the from A is the important bit, and that's where you want to start. That's where you need your north line, and then from A to B you just have a straight line. Sometimes they draw one on the map for you, sometimes they don't, in which case you need to draw it in. You need a straight line from A to B. Now the bearing is simply the angle measured clockwise from north. So in this case it would just be that angle there. Sometimes they draw the map to scale and you have to measure this angle with a protractor. Sometimes they'll give you various other angles on the picture and you have to use angle fact to work it out, and you can't use a protractor to measure the angles. But either way, it doesn't really matter. As far as bearings are concerned, it's the angle measured clockwise from north. So maybe this one you're supposed to measure with a protractor, and we measure it and it turns out to be 50 degrees. There's one slight thing though you've got to bear in mind with bearings, which is that any bearing you write must be 3 digits. So if you measure the angle and it's only 2 digits, then you have to stick zeros on the front until you've got 3 digits. So in this case, the bearing of B from A would be 050 degrees. And the 0 on the front is really important there. So if you measured an angle and it was only 9 degrees, you'd have to write it as 009 degrees. It must always be 3 digits. If it's more than 100 degrees, so if you've got an angle that's 120 degrees, then you can just write it like that. You don't need to put any extras on there. If it's already 3 digits, that's great. But if it's less than 3 digits, you must stick zeros on the front to make it 3 digits. That's a bit of an oddity surrounding bearings, but it's very important that you get that one. So the bearing of one point from another point, wherever you start is where you need the north line, and it's the angle measured clockwise from north. Now that clockwise thing is the other thing that's quite important here. If I give you a different example, in fact, if we leave those there, in fact we can leave the angle there as well. Let me just change the way I ask the question. So we're going to say we want the bearing this time of A from B. So instead of starting here and going to B, we're going to start from B. From B is the important bit you need to spot first, and we're going to go to A. So if you're starting from B, you need a north line at B, and if there isn't one, you've got to draw it in. So that's the first thing. Draw a line straight up. That's going to be your north line. And we need the angle clockwise from north. So be careful. It's not that angle there. It's not this one in there, because that will be the angle anti-clockwise. You have to go all the way around the circle to get the bearing. So in this case, if I just move that temporarily, we need the angle all the way around and back to there, this angle around there. Okay, so this is going to be the point Put my B there. And that's the angle that we're going to need to find out. And this is where they might use the parallel lines facts, for example, because the north lines are always going to be parallel. They may use other angle facts and things, and you have to try and work out what the angles are. So as I say, I'm going to do in-depth problem solving in the next video, but just briefly to explain how you might work this one out. Those two are parallel, which means that this one and this one here are internal or interior angles. So those two have to add up to 180, which means that this one is going to be 130 degrees. And then you've got angle all the way around in a full circle, it's got to be 360 degrees. So if you take 130 degrees away from the 360 degrees, you're going to get 230 degrees. Yeah. So 230 plus the 130 gives you 360, which means that this angle here is 230. But the key thing you need to realize here is that it's the angle measured clockwise from north, that way around. Yeah. Not this one here, but that one there. You've always got to go clockwise. So it's often the facts, the kind of angles involved aren't necessarily that hard, but just keeping track of where you're starting from and where you're going and which angle you're supposed to be measuring, that can be the difficult thing. So you're spotting the where it's from first. Always look for that first. Make sure you've got a north line there and go clockwise in the angle until you get to the line that points to the direction you want. In this case, we're going towards A. So, last little thing to say then, if you were measuring angles here, you might find it's quite hard to measure an angle around the outside. If you're using a little semicircular protractor, you're like, oh, it doesn't fit, it's not big enough to go around there. In that case, just measure the one on the inside, work out what it is, and then subtract it from 360, just like we did when we were using this one here. So those are the things to bear in mind for bearings. It's always the angle clockwise from north. You must write it with 3 digits. If it's not 3 digits, stick zeros on the front until it is. As I say, watch the bearings problems videos, and I'll do more problems in depth and show you how you can solve these kind of problems in practice.